Hello, good afternoon, good morning, good evening, depending on where you are seeing this video from. So we started our journey of Pandas tutorials or Python for data science. And today I'm very excited because we are going to build our first model in machine learning. We are going to build our first machine learning model from scratch to finish. Now, the first thing you need to know before building your model is that you need to have scikit-learn library installed in your computer. Now, what is scikit-learn? Scikit-learn is a pandas library for machine learning. It is one of the library used for machine learning. Now, it is mostly used and it is very user friendly. It is easy to use. It's an open source. Now, there are other libraries for machine learning, but scikit-learn is one of the most used ones and it is very friendly. Now, how do you install your scikit-learn? Go to your Panda, your Jupyter notebook, and just say pip install scikit-learn. Please follow exact what I'm doing. Now, once you hit on enter, it's going to install scikit-learn. Now, because I already installed scikit-learn, I will not be installing again. So if today is your first day of seeing this tutorial, my name is George. I am a data scientist. I am teaching Python for data science. So do well to follow my page, subscribe. Also do well to like, comment, share this video to your loved ones, and as well put your comment on the comment section. So without any further delay, let's dive into our tutorials. Now, the first thing you need to know, I need to do is first of all, import your library. So we are going to be importing basically 4 to 5 libraries. Don't worry, I will explain every library I import. So the first thing and the most important one you need to import, don't always forget, is pandas. So you say import pandas as PD. Now, the next thing you need to import now, scikit-learn is a library that comes with other packages for different operations. Now, we are going to be importing some libraries from scikit-learn to aid us work with machine learning. So the first one we are going to import is one of the algorithms. Now, listen, scikit-learn comes with various algorithms. We have linear regression, we have a decision tree classifier, we have rainforest. But today we are going to look at how to use decision tree. Now, the first thing you need to do is say from sklearn dot model selection import tree underscore test underscore split. All right. So basically, this is one of the library we are going to use to do or to split our data set into train and test. Now, the second thing you need to import from scikit-learn, you say from sklearn, okay, dot tree. This is the main model which you are going to use. Import with this capitalization is very important. Decision tree classifier. Now, the next model we are going to import also is from sklearn.metrics. Okay, import or accuracy underscore score. All right, I think those are what we need. Okay, we have imported our train test split. We have imported our decision tree. We have imported our metrics. Okay, let's go ahead and run this. All right, so we have been able to successfully install or imported our library. So like I said, we're working with basically 4 libraries. Pandas is for to read files and for data analysis. model selection, we are importing trains, test, and split, is to help us to divide our data set into train and test. Now we have scikit-learn.tree to import decision tree classifier. This is the main model which we are going to that will help us to train our model. Now, sklearn.metrics, we are importing accuracy score, is to help us evaluate the model if is giving us a positive yield or is giving us a negative yield. So the next thing you're going to do now is you are going to separate your data into X and Y. Now, sorry, we are going to first of all read our data. I forgot that part of it. Okay, we are going to read our files. We are going to read our files. Okay. Read file. All right. So the next thing we are going to do now is to read our CSV file. Now you see df equals to pd dot read is a CSV file, CSV. And the name of my CSV file is liver underscore disease underscore data dot CSV. Now, if I go ahead and look at the head part of it, of our data, we're having error. What's the error? The PTW CSV, liver disease or CSV. No such file in the liver disease data. Sure. Liver disease. All right, so there's a misspelling here. I actually have it, so let's say liver underscore disease underscore data dot CSV. So you can go ahead and execute it. Okay, I misspelled it, so that's why you need to always look at your spellings before you execute your code. So this is the data we are going to work. Now, the first thing you need to do is that we want to see if this person has liver disease. Now, 1 is that this person have liver disease. Now, 0, it means this person does not have liver disease based on our diagnosis, based on our data. Now, we say age 58, gender, and BMI. All these ones are the clinician or diagnosis or tools to diagnose if a patient has liver disease or not. Now, so what we are interested is in the diagnosis. 1 is that this person has liver disease. 0, the person does not have liver disease based on this attribute we are having now. So the next thing we need to do is to separate our data set into X and Y. Now, the part of it is going to contain all of this information, excluding diagnosis. Now, we are separating this into X and Y to enable us to feed in the data set into our machine for our computer to do or to understand this data and to make predictions. Now, what we are going to make predictions of is just this diagnosis. If this patient has liver disease or not. Now, the first thing you need to do is, okay, capital X equals to PD dot, you need to drop every other column. Okay, you see columns equals to, all right, you are dropping this column here, this diagnosis column. We are dropping it. We don't need it in our X data. Now you see, okay, drop diagnosis. Now, the next thing is a small letter y equals to PD. Now, all you need to do, you want to get your diagnosis back. You open your square bracket and you call your diagnosis. All right, diagnosis. You will go ahead and run this. Is giving us error. Model pandas has no attribute drop. Okay, all right, sorry. Okay, PD dot X equals to df dot, sorry, df dot drop, and here we see BF, and we call our okay, fine. We have been able to to drop this column from our data set diagnosis. And here we have been able to do what? To get back our column with diagnosis. Now, if we go ahead and want to execute to see our X data, now this is our X data. If you look at this data, you have every other columns, exception of diagnosis. There is no diagnosis function, diagnosis column here, because we drop diagnosis from this our data set. Now, but if you want to inspect our Y variable, you see that it contains only the diagnosis column without every other column. This is how we can drop and also call back our column while working with machine learning. So the next thing we want to do is that we want to splitting our data now into, that is why when we imported this string from skname, the model selection import trace test and split, we want to split this data set into trainings and testing set. So how do we do that? It's okay, capital X string. Don't forget your X variable is always in capital letter. All right, X underscore train, comma, and X underscore test, comma, small letter Y underscore train, comma, and small letter Y underscore test. All right, equals to, we now call it train underscore test underscore split. Now we want to give it attributes. We want our X and Y, then the test size should be based on your own, but me, I want to use 0.2, which is I want to use 20% of my data set for testing, while 80% for training. If I go ahead and execute this code, okay, it's working effectively. So we have successfully splitted our data set into X train, X test, Y train, and Y test. So the next thing we want to do now is to train our model. How do we train this model? The first thing we need to do is that we want to see, okay, we want to call the actual model. Okay, I say model, it can give you whatever name. I say model. All right, so I'm calling this. Okay, let me just copy the decision tree. All right, so model is equals to this. Sorry. All right, so, all right, and you open and close, you do your open and close parentheses. Okay, I have successfully called my function. Now, the next thing we need to do is to fit in data into this model. I call it mod. So let me just put this and we run this. All right. So as a model dot fit, I want to fit in this data. I want to fit in our X tree. Okay, X tree and our Y tree. All right. So if I go ahead and execute this, all right. So if you see this, it therefore means that you have successfully imported your model, which you are using decision tree classifier. Now we have been able to call our function decision tree classifier, how we have been able to fit our data set X train and Y train. Now the next thing we want to do is to actually make prediction. Now, how do we make prediction? All right, that's okay. You give it a new variable. It's okay, Y pred. Okay, sorry about that. You say Y underscore pred equals to, all right, you call your model dot, okay, you say predict. All right, you pass in your data. Now let's see something. Let's just say model dot predict. Let's see something. Let's just call X underscore now test. If I go ahead and run this, this is our test data. Now, this is based on this information we feed into our computer. It's okay, computer, learn this pattern. If somebody is age 58, gender, let's say male for a female for 0, 1 for male. Now, BMI, this, all these attributes. Now, okay, predict if this person, based on the data set we have given, with this diagnosis. Is this person, does this person have liver disease problem or not? Now, after everything, this is what the computer has been able to predict, and this is the outcome of the prediction. Now, let's go ahead and evaluate and look at our, let me put another cell. Let's look at our Y test. Okay. Now, it's okay. Let me import NumPy. Okay. Import NumPy as NP. All right. All right. So I want us to compare our actual value versus our train value. You said, okay, let's say y underscore pred, all right, underscore pred equals all right. So let's just call our y. Now, if you look at this array, or you can just say np dot array, all right, array. You pass in your y test, all right, and you go ahead, execute. All right, so if you look at the train data set and the original data set, all right, so you see that our predictions, our computer is able to do or to predict. We look at here, we have variable, we have 0110, while we have 0110 as well. We have 000001, and we have 1, 2, 3 zeros here. Where we have 1, 2, 3, 1, 2, 3, 4, 5 zeros here before 1. So now this might not actually be 100% accurate. The accuracy might not be totally 100%. That's why we are going to evaluate our model to see the percentage of its accuracy. Now, out of this is our test, and this is the actual, okay, let's say train. All right, let's say train. Let's go ahead and rerun this. All right, so this is what, no, let's use test. Okay, this is the test. All right, so computer has been able to do what? To evaluate, to make predictions based on the information we have entered in the system. Now, if you look at it, it's not 100% accurate, but it has a certain level of accuracy, which we are going to evaluate very shortly. Now, you see here, we have 011 and 0. This is the actual, this one is the actual value, the actual data set, and this is the predicted data set. So now, if you look at it, there is a level of accuracy. Now, we are going to look at it in a short while. Now, let's put this in a variable, say prediction, okay, equals to, I'll rerun this. All right, so we can as well delete this. Now, what we want to do is to evaluate our model. If you look at our model, our library, we say from sklearn.metrics, import accuracy score. We want to look at the percentage of accuracy. Now, how do we do this? We give it a variable, let's say y underscore predicts equals to model.predict, all right, predict. All right, we now pass in your what? Your y underscore test and your prediction. Now, you are comparing between the data set you imputed, the actual data set, which is the y test. Now, and prediction, this is the predicted what? The predicted data set. So we want to do what? To compare if it is accurate. Now, what do we do? We say, okay, we go ahead and run this. Okay, we are having, all right, sorry about that. Let's use score equals to, all right. All right, so we want to look at accuracy, accuracy, accuracy underscore score. All right. So we are removing this. All right. So let's go ahead. All right. So let's go ahead and call this function score. Now, we have been able to evaluate our data. Now we have 0.85 means our accuracy score is at 85%. It's not a bad one. So from the data we have been able to feed in into our computer, it was able to compare the data, make predictions, and the accuracy of this data set of this prediction is giving us at 85%. So it is not bad. Now, very important thing you need to understand before you venture into your data machine learning proper, you need to ensure that you understand your data set. Now, there should not be any null value, no missing value. I taught us how to replace missing value in our last tutorial. Now, and also in working with machine learning, you cannot use object. Okay, let's look at df.d types. All right, let's look at our data types. No, df d types. I was trying to just keep my memory now. I want to show us the data type. So in this data, look at this data, they're all integer and float. You don't need any object, you don't need any string to work with. Now, if you have peradventure, you have this gender as male and female, please convert it to 0 and 1. You know that, okay, 0 is for female and 1 is for male. And peradventure, you also have in your, let's say, diabetes, say yes or no. If you have anything that yes or no, please convert it also to 0 and 1. What machine learning does is that it only accepts data from integer and float. It does not require any string. So you need to ensure that your data set is of integers and float. And also there should not be any missing values. Now, if I want to change my data frame, I say, okay, df dot is null. All right. Now sum it for me to see, okay, let's say if I have any null value. If you look at it, I do not have any missing value. It therefore means that I am very good to go. And look at this data type. They are all in 64-bit. So I'm using one of them that all they are integer. Now you don't need to work with strings object. All you need is integer and also float. Now you can also convert this float that has decimal point into an integer, which I will be teaching us in subsequent tutorials. So I hope you find this video helpful and impactful. Please do well to follow, share, comment, and also like. Encourage me to keep doing. If you have any question, please drop it at the comment section. I will do my best to ensure I give you a clear answer. If it means to do a video just to explain in details what you're asking me, I will do that for you. Please don't forget, my name is George. Help me to grow this channel, this page, by liking, subscribing, also by following my page on Facebook. Do well to ensure you share this video to your loved ones. See you in our next tutorial. Please, if you do have any question, don't forget to drop it. I will answer in my next tutorial. Thank you.